Today we're looking at Lesson 8.1, which is adding and subtracting polynomials. We're also going to be looking at what a polynomial is. Here are three different kinds of polynomials. Monomial, if you look at just the prefix of the word, means one, so a monomial is one term. Binomial means two, so that's going to be two terms. And trinomial means three, so that will be three terms. If it's any more than three terms, it would be considered just a polynomial. Notice also that with the terms, they can only be added or subtracted. They cannot be multiplied or divided to be considered a trinomial or a binomial. Then we have what's called degrees of the polynomials. If you have just a monomial, you're going to add the exponents of all of its variables. So for example, if I had 5x squared y, I would have to add the exponent of 2, and then there's an exponent of a 1 when there is none, and add them up to be 3, and that would be considered the degree of the monomial. If it is just a number, which we call a constant, it has a degree of 0, and if it's the number 0, it has no degree. A polynomial, like I said in the previous slide, is that it has more than one term. Usually more than three terms is when we call it a polynomial. But if you're trying to come up with the degree of a polynomial, whether it be a monomial, binomial, trinomial, or more, it would be the greatest degree of any of the terms in the polynomial. So if I had 5x cubed minus 2y squared plus 3, my degree, and notice that my exponents are in order from greatest to least, my degree would be a third degree, which is the greatest exponent. When it's not a polynomial, you're looking for if it has a variable exponent, so like 8 to the a would not be a polynomial, or if it has a variable as the denominator, so 3 over x, that would not be a polynomial, or if it has a negative exponent, such as 10 to the negative 2. Those would all not be polynomials. Then we have what's called standard form, which is basically putting the exponents in order from greatest to least. And if you put them in order from greatest to least, after they are already in order, then you can decide what the leading coefficient is. A coefficient is the number in front of the variable, and the leading one would be after you put it in order, so it would be the first one. So in this case I put 4 is the leading coefficient, and 3 is the degree of the polynomial. Since it has 4 terms, we would just call it a polynomial, so we would say third degree polynomial. For these, we're going to determine whether these are polynomials or not, and then say the degree and what type of polynomial, whether it's a monomial, binomial, or trinomial. So this first one is just the letter x. Since it doesn't have a variable exponent, a variable denominator, or a negative exponent, and it's just one term, we would also need to figure out that the exponent is a 1 when it's not written there. So I would say this is a first degree monomial. The next one, notice, has 2 terms, so that's going to be a binomial. But we need to make sure that each variable has an exponent to determine the degree. So none of these have written 1, so they're all a 1. if we determine the degree, it's the greatest of all the exponents added together if you have different monomials. So in this case, the degree of the first term is 2, but the second term is 3 if you add up all the exponents. So we're going to go with the highest, which is a third degree, and it's 2 terms, so it's a binomial. And then the next one, again, you have your variables. So I'm going to put exponents there, and then there's an exponent of 0 when you have just a number. And this is already put in order, but we can combine like terms before we're finished. So this can be combined with this, but that doesn't change the exponent. It's still 1. So the highest exponent is the 2. So we're going to say second degree, but once you put the two terms together to get positive 2y, you're only going to have 3 terms, so we're going to say that it's a trinomial. And then the last one, notice it has both a variable exponent and a negative exponent, so that is not a polynomial. The next one here, we're asked to put it in standard form and then tell me the leading coefficient. So again, standard form is putting it in order from greatest to least, so in terms of the exponents. So I always assign the exponents if they're not written there, just to make it clearer. So all numbers get a 0 exponent, and all variables that don't have exponents have a 1. So we're going to put it in order, with the 4 coming first, then the 2, then the 1, and finally the 0. So this is put in order from greatest to least, so it's in standard form. The leading coefficient is the first term's coefficient, so it's a 4. The next one we're also asked to put in standard form. So again, we're looking at the variable's exponents, or any of the exponents. That one has a 1 and the 10 has a 0. So the highest here is 7y to the 6th, so that is negative 7y to the 6th will come first. Then 3, so plus 5y cubed minus 2y squared plus y plus 10. And if you ever need to combine like terms, they have to be with the same variable and the same exponent for you to combine them. So none of these can be combined. The leading coefficient is the first coefficient once it's in standard form, so it's negative 7. Here we're asked to add the exponents, so there's 2 different methods. I think that the horizontal method is probably the easiest, which is just combining like terms as you go. Or you can set up the like terms one on top of the other and subtract or add like a normal addition or subtraction problem. Either one would be fine. So we'll do the horizontal method for this one, which we would just find the exponents and the variables that are the same and see if we can combine them. So 5x squared is the same as 3x squared. So if we go left to right, 5x squared plus negative 3x squared is going to give me 2x squared. Then you have negative 3x and 6x, so negative 3x plus 6x, which would be plus 3x. And then you have 4 plus negative 3, which is the same as 4 minus 3, or 1. And so we would have it in order from greatest to least in terms of the exponents, and this would be our answer if we add the 2 together. So the next one we're going to do is also with addition, and I'll show you the next one using the vertical method. So what you want to try to do is pick out all the like terms and line them up, almost like you're doing the elimination process for solving systems. So you're going to line them up like you would add or subtract. So y to the fourth. And then I'm looking for another one that has y to the fourth for the other parentheses, which is here. So y to the fourth goes on top, and then negative 2y to the fourth goes on the bottom. And then we're going to keep going. You have just one 2y cubed, and that's not added to anything. And then you have a negative 3y and a 2y. And then you have a 7 and a negative 11. So notice how I put them kind of like in columns. And then you're just going to add each column. So 1y to the fourth plus 2y, or plus negative 2y to the fourth is negative 1y to the fourth. 2y cubed plus 0, okay, because there's nothing there, is also just 2y cubed. And negative 3y plus 2y would be negative 1y. And 7 plus negative 11 would be negative 4. So I'm going to rewrite this. If it's a positive term, I separate it with a plus sign. If it's a negative term, I can keep it as a minus sign. So this is going to be my final answer. Now the next two are subtraction. Since I prefer the horizontal method, I'm going to be using that method for the next one. So we're going to do 4x cubed minus negative 2x cubed, since those are both like terms. And then negative 3x squared minus x squared. And then 6x minus nothing, so it's just going to be 6x. And negative 4 minus negative 2. So I'm going to do each one of these separately and put it together as a polynomial. So 4 plus 2 is 6x cubed. Negative 3 minus 1 is negative 4x squared. This is just 6x, and this is going to be negative 2. So if I put it in order, I have 6x cubed minus 4x squared plus 6x minus 2. And that would be my final answer. One more like that, and then we'll do a word problem. So 8y is the same as 12y. So we have 8y minus 12y. Then negative 10 minus 7. And then 5y squared minus 0, because there's no other term with a squared. And then it's 0 minus negative y cubed, because there's no other term. So we have negative 6y, negative 17, 5y squared, and positive y cubed. And now I'm going to put it in order from greatest to least. And that would be my final answer. Now the last problem says you have two equations. One represents the number of cell phones, P, and digital cameras is the other one. That's represented with C. And then the M is represented for months. And we have two equations. We need to write an equation that represents the difference in the monthly sales of cell phones and the monthly sales of digital cameras. So we're going to take the two equations and subtract them. So if you have 7m plus 137 minus 4m plus 78, we're going to do what we've done the last couple problems and subtract like terms. So 7m minus 4m is 3m, and 137 minus 78 is 59. So my equation is going to be 3m plus 59. And then we're using the equation to predict the difference in monthly sales in 24 months. Since m represents months, we're going to plug in 24 for m. And we get 131 months. So those would be my final two answers. And that concludes Lesson 8.1 on adding and subtracting polynomials.